Hey, Grayson, how you doing, buddy?
I'm all right. I was winding down for the night when I got your message, so I'm down to talk. What's up?
Awesome. No, I just not a lot. It's only it's 3:55 in the afternoon here now, and had the afternoon off, and I had a little bit of a chat with another Glober before that guy. Fight the flat Earth and all.
Oh yeah. I'm familiar with FTFE.
Familiar with him? Yeah. So he invited me onto his channel, had a brief chat. That clown tune kicked me off, which is really funny. But other than that, yeah, I just felt like having a chat with somebody who'd like to talk about their opinions on the state of the ground they live upon.
The shape of the Earth, yeah.
Yeah, why not?
So there weren't any particular lines of argumentation that you had wanted to talk about?
No, if those guys, they were just trying to accuse me of being a Nazi because
Oh,
I once posted a thing about Aryans or something, and that apparently makes me a Nazi sympathizer or an outright Nazi. So, yeah,
well, the Aryans were a real historical people, like around
right,
the Iranian plateau, like part of the Aryan migration into India.
okay,
So there is an actual archaeological basis for them in the like Bronze Age to Iron Age kind of time frame.
right. So you couldn't really particularly make any particular connection with them and Nazi Germany, though, could you?
Well, the Nazis had an incorrect historical understanding of the Aryan people as some sort of race of Ubermensch that, like, I mean, their understanding of history was pseudoscience, and they were largely completely wrong. But a lot of white supremacists build up the Aryan people as some sort of mythical white race in the past or something. So I don't know.
Right,
There's
right, yeah.
certainly it the Nazis like lots of stuff. They ruined a lot of cool and interesting things. Like the swastika used to be a Buddhist symbol. The Hitler mustache, was the Charlie Chaplin mustache. So yeah, I mean, I don't really know what you posted, but it's not really on. I mean, we were going to talk about the shape of the Earth, not really talk
For
about.
sure, for sure, for sure. Yeah, and that's all I was ever been about. This Toon guy found some obscure post reference that I made, and it just happened to mention the word Aryan, which is allegedly backdated towards the white people. And somehow I seem to think that a lot of the architecture that's all around the world, Tartarian, as it's called, which Tartan and Aryan combined, has had a widespread influence all over the world. You can see it everywhere: Russia, China, Japan, America, even in Australia. There's similar sort of influence, and seems to suggest to me that there's something that's been hidden from our history for whatever reason. And to me, maybe it's part of the same cover up that tells us we live on a spinning ball hurtling through space. But,
I don't know. That's
it
a,
is
that's a
a
bit
bit of a
far
stretch.
fetched.
Yeah.
I mean,
It's a
the
stretch.
the reason that people build pyramids everywhere is that they're the most stable architectural structure to build height. Like, it's a lot more stable than a
Definitely.
tower to build a pyramid because it has a stronger base. So that's why you see pyramids everywhere. It's just geometrically, that's the
Oh,
the
yeah, but I
best.
wasn't talking about the pyramids. I'm talking about like, say, the White House, big thing, pillars, dome,
Oh,
flat
well, the
roof,
White
flat floors.
House, like American architecture at that time was intentionally modeled off of Rome, and the Rome model they modeled theirs off of Greece, and Greece modeled a lot of their architecture off the Phoenicians, who were modeling a lot of theirs off of the Assyrians and Sumerians. So I mean, you can trace the actual threads of this architectural style through history.
For sure, for sure. Yeah. No, to me, it's just very interesting, and that's why I don't think bringing up the term Aryan is necessarily being a Nazi. Like, I just can't make the connection myself, and I don't know why Toon gets so vindictive, then you know,
Yeah,
vindictive about
vindictive
it,
or
but it
whatever.
is what it is.
I really can't say anything about that.
No, no. Fair enough. No, I find architecture is quite interesting, and yeah,
So did you see my most recent flat Earth debate was against Flatzoid on Modern Day Debates? Did you catch that?
oh, I only caught a little bit of that one. Yeah,
So
was
in
that
in
like
that,
about a week ago or 2 weeks or something
I
like
think
that?
about a week ago, yeah.
Yeah,
Um,
yeah, I caught some of it.
the
Yeah,
the primary things that I brought up were, of course, the sunset, which is probably my favorite argument against flat Earth, but
yeah,
also the flight times in the southern hemisphere was another one,
yeah.
or just the southern sky, like how in Australia there, you when we look at the same moon, it looks upside.
Oh shit! Sorry, man, I just pressed something.
Yeah. So what I was saying was that the moon or like the Southern Cross, like the moon in Australia is upside down compared to the way I see the same moon when I look at the sky, that kind of
Yeah.
thing. So those are the main arguments that I presented in that debate. I don't know if
All
you had
right.
any
Well,
comment on
the
them.
the moon one's quite an easy one. I mean, like if we look at each other, your left is my right. It's as simple as that,
Yeah.
Like, and so if, say, for example, I drew a 6 on the ground, to you it's going to look like a 9. To me, it's going to look like a 6. So that's
Hmm.
all the moon's doing. We're just looking at it from different sides, both looking up at it, and
Yeah. So the issue that I have
that's
with
easy.
that, because Flatzoid brought up the same thing in our debate, but the issue that I have
Sure.
with that is that if we were to actually do like an experiment like that, um, the depending on the angle that we were looking at the 6 or the 9, as it were, you would see it at an angle, and it would be sort of the shape would be distorted. So instead of a perfect circle, we would
Yeah.
see sort of like a more compressed thing, depending on how far away we were from the equator or whatever. So
That
and we
that
don't
does make sense, but as long as you understand the distances involved, we're talking about some pretty massive distances, the sort of thing that you can't really replicate on the ground. On the ground, we can only see a few miles if we're lucky on a good day. The higher you get, the further you can see. But when you're looking at higher things, the further you can see them. And so if the moon is actually projected from a very long height away, and all we're seeing is the personal projection of it, it's actually flat to our appearance. And yeah, by all rights, it should appear distorted as you got further, nearer or away from it. But it's it's still going to present the exact same image towards the viewer who's seeing it, where they're seeing it. It's just the way it works.
So what do you think that it's odd that whenever we like the very famous experiment that a lot of college students do where they bounce a laser off of the moon, right? And it takes about 2 seconds for the light to hit the moon and come back to us. Do you think that that's any indication of how far away the moon is?
No, I would think that if everything was moving at the speeds that we're told that they're moving, I would think that would actually be a ridiculously impossible thing to replicate. I mean, just the fact that the Earth itself moving. So if it's sending out the beam, if it's shooting it out, and within 2 seconds we've moved, X number thousands of miles, what are the chances of that beam being reflected exactly back to us and giving us a true indication of where we would be?
Well, the whole system is moving like relative to each other, so it's not really a big issue. Like the moon and the Earth are both moving in their orbits. I mean, it's not like they're moving in a straight line, and then when we send the light beam out, both the Earth and the moon have moved past it. It's not like that.
Yeah, yeah,
2 seconds.
but the light itself doesn't have that same gift that we grant everything in the atmosphere, because it passes through the atmosphere,
Yeah.
and so it should shoot back behind us. Like
Why?
the globers love to say, "Oh, well, the whole atmosphere moves with the Earth, and so therefore everything moves." Well, why would the light also drift with us at the same time and bounce back in 2 seconds? Man, that's a shitload of distance.
Does conservation of momentum not apply to light?
No. Why would it? Light isn't physical.
Light has momentum, though.
Yeah, but it can only travel one direction. I mean, what is
It
it?
can definitely
Is this
travel
light
more than
traveling
one direction.
360 degrees as a laser and bouncing back again as a laser? I don't quite get that.
What's not to get? You shoot a laser out, it travels in one
Yeah.
direction and bounces off something and comes back. It's not very complicated.
Well, no, unless you put motion into the picture.
Not really. I mean, you
Yeah,
if you
really.
if you're
Like,
driving in a car and you shoot a laser and it bounces off another car and comes right back to you, the
yeah.
whole system was moving, but there's still it's just the same amount of complicated as it was before.
Yeah, but that's like, talking about half a bee's dick in comparison to a big mammoth stick that's fucking, quarter of a million miles away.
Yeah, we're talking about the speed of
We're-
light, though. I mean, that's
Yeah.
a really fast speed.
Yeah, I know. But at the end of the day, it's still a far easier assumption to assume that you're standing still and the moon is barely moving and just moving enough that you can actually do it. I mean, surely the Occam's razor says the simpler explanation with the least amount of assumptions is more than likely the most correct one.
Okay, I don't really know how that applies here, but
Well, it applies to everything, whatever endeavor. If you're saying that the Earth is moving 67,000 miles an hour around the sun, and the sun is moving quarter of a million miles an hour through the galaxy, and the moon is only going 2,280 miles per hour around us, and we're meant to be able to bounce light off the moon back to us as all these motions are happening.
yeah, the Earth and the Moon are moving together. So yeah, the Earth, like they're moving the same, like the
Well,
Earth's movement relative to the center of the galaxy is going to be the same as the Moon's. The Moon and the Earth are also moving around the sun together. So a lot of that is like there's nothing that would even would contradict it all.
okay, but the moon is still going around the Earth, right?
Yeah, but I mean,
Yeah,
look,
but isn't the Earth going around the sun? So the Earth is
the
actually
light
going
takes 1
a linear
second to get
distance.
there and 1 second to get back, roughly. So how much is the moon gonna move relative to the Earth in 1 second? Not very much.
Thousands of miles. Thousands.
Not very much.
Probably
For
not.
the light at that point, I mean, come on. So what did you think about I don't remember in our debate if we talked about the sunset at all. I don't remember your explanation for how the
We
sunset.
did. And to be honest, I didn't actually expect that you'd come on and take this call as quickly as you did, which is pretty cool that you did.
Well, I like talking about these subjects, you know?
Yeah, no, that's awesome, and I do appreciate that. And yeah, absolutely. We did try and talk about the sunset, and I wanted to keep getting back to it. And every time we did, we sort of a little bit distracted. But to me, the sunset is the most obvious and logical thing of how perspective would work on any sort of surface, especially a flat surface. Is the further something away is the lower it's going to appear, and the height of the viewer determines the convergence point. So that's why your horizon is only a few miles away, because that's due to your height. And the higher you got, the further your horizon will be, but you'll still have a convergence point, and everything is still going to converge to that point, regardless of its height. Yeah,
Yeah, but that's not
the
a
perspective issue.
sunset, right? I mean, you're just talking about
It is.
perspective, but in perspective, we don't see things disappearing bottom up.
Yeah, but so you're describing it as disappearing bottom up.
Yeah, that's what we
I would
see.
describe it as disappearing bottom first.
Okay,
Because it's
sure.
just as it recedes, it's getting hidden
Well,
bottom
I'll
first.
agree bottom first, fine.
Okay, so the things in our way that aren't diminishing because they're standing still will stay there and block the thing that is moving away, and then point what's so far away, it's obscured by it, and therefore you can't see it, and it will seem to disappear bottom first.
Right. But earlier you had said that, with like the laser, or when you were talking about light earlier, you were talking about how it goes just in one direction. It's like it's one way. So if you're thinking about this in your mind, like in three dimensions, you have the sun that's really high up in the sky, and you're saying that the bottom portion of that is blocked by some object on the Earth's surface that's only a couple feet high or something. And so how does that make sense? How could the light travel in one direction from the sun that's really high up in the sky and get blocked by something that's really low in the sky that's lower than the height of your eye?
Well, it takes. Well, okay. I wasn't expecting that last little bit. Lower than the height of your eye. No,
Yeah, like
most of
maybe it
those
would
things
help if
are
I
above.
if I could draw a picture for this or something. I don't
Yeah.
really have MS Paint. I don't I don't really know how to make
I
this
was, as I say,
so.
I wasn't expecting you to come on so quick, and I was just going to chill for a bit. But it's all good.
But like, okay, so if I'm understanding this correctly from what you're saying that the bottom portion of the sun is blocked first because there's actual physical objects that are between it and your eye, right? Is that what you're saying?
Are you like doing a share screen?
No, no.
Oh, right.
I don't know how to draw on my freaking. Maybe if I could figure this out. I've never drawn on like MS Paint or any of those things like that. So I'm just trying to paint a picture with words right now, and admittedly, it's a lot more difficult than a picture.
All right. Yeah, just give me 2 seconds if you don't mind.
Yeah, sure. Yeah, I understand. Let me see if I can figure out how to what what I can draw with on this computer.
I should have done that before I got started. Oh boy. Okay, now I feel better.
Well, hopefully that makes you more open-minded and not just more clouded.
Hopefully, we'll see. Wash it down. Hoorah. Rightio. I'd just like to say g'day to Alan and Shawnee B sitting in the chat. Good to see you guys. Shawnee B says horizon equals horizontal, and that's exactly right. There's no other way that the horizon can be.
Are you familiar with what is known as an etymological fallacy?
Etymological fallacy.
Yeah, so that's where it's like a logical fallacy where you conflate the meaning of a word with its etymology. So like the origin of where the word
Okay.
comes from, which are like two different things, of course. So like conflating the two is the etymological fallacy.
I can see that's a reasonable term, but at the same time, I also think that the etymological truth of the word is actually revealing far more of its actual meaning, because that's etymological. So I
I
think
don't know. The meaning
horizon
is
and
definitely.
horizontal.
I would definitely put the meaning of a word as priority in order to determine what the meaning of a word is. So I would
Yeah,
not
yeah.
say that just because a word maybe has its origins meaning something else, that somehow takes precedent over what it means today.
Well, of course, yeah, words often change meaning, but you know, often the etymology of it will reveal more of its true meaning, and that's why I say horizontal and horizon. That you can't really mix those two up. I mean, sure, there's plenty of words you could say have changed over the time, but if you're trying to suggest horizon and horizontal no longer mean the same thing, then yeah, fine, I could challenge that.
They are different words. That's kind of
Oh,
why.
well, one's got tool on the end. Yeah, true.
Yeah, they do mean different things. Just objectively speaking, like
Well,
horizontal means something different than horizon. For example,
no, no, no,
one is
no,
an
no, no,
adjective.
no, no, no. It doesn't. It means
Look,
exactly that.
Iron horse. One is an adjective and one is a noun. So like they are different words.
That's okay. So, yeah, but
But that just
well,
means that they're different words.
but the horizon is actually an optical illusion. So you can't even really say it's a noun. It's a, what's it's It's
It's a
a
thing. A noun is a
it's a
person, place, or
mythological
thing.
noun. It's an imaginary noun, but it's not really a thing. It's
Well,
just
look,
a
Zeus is a noun, and it's still a mythological, imaginary thing. So it
Zeus.
doesn't mean that Zeus or Cerberus or Hades, whatever. Those are all
Yeah, but what's it
mythological.
got to do with horizon? We're talking about the horizon. This is very
Well,
specific.
you were saying that it's not a noun because it's imaginary and mythological, and I was saying there are
Well,
tons of
but
imaginary mythological nouns, and
in particular to the
primarily,
horizon, to the horizon. You know, let's
and
start
I
there.
would agree that, like, there's an apparent horizon that's like the visible
There you
horizon.
go.
I agree with you on that much, at least.
The
The
physical
horizon,
horizon is apparent.
yeah, the horizon that we see is just the apparent horizon. I agree with you on
Exactly.
that, and
Exactly. That's why it's
it's
called
too,
perspective, because it's all apparent. It's everything we see is perspective.
and it's influenced by atmospheric conditions. Yeah.
Well, to a degree, but not hugely. You know, atmospheric conditions might change things over a period of time, but generally they're pretty consistent. You know, it's not that big a deal.
So what is it that is obstructing the bottom portion of the sun during a sunset?
The obscurity point of your personal perspective of the ground rising up beneath you to the horizon, the apparent horizon. It's the optical illusion of how we see in the distance.
So in
3D
that,
vision goes both ways. We've got the upwards and we've got the downwards, and they meet horizontally.
so
It's
you're
just
saying that it's like because of the limits of our angular resolution is of our eyes? Is that what you're saying?
uh, sort of, kind of. Like, yeah, a bit of both, but it's also the convergence effect
So
of everything rising to the horizon.
again, though, when we're talking about perspective, what happens when objects recede in perspective is that they get closer to the horizon, but they never get obstructed by the horizon, like the bottom first. They just get smaller and smaller and closer to the horizon, but they're never obstructed by it.
It depends what you're talking about. If you're talking about something on the water, as it goes away, you probably can keep zooming into it until it disappears due to angular resolution. But when you're talking about things that are way, 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 way above that eye line, they're converging the other way, man. So they're just going to get blocked much closer than they should naturally. But that's just how it is because of our height. We're really, actually, really low to the ground, like really low. We see nothing. A few miles, it's nothing. So these really high things, we send them far enough away, but until, once they're far enough away, you just don't see them anymore. And they get obscured by the stuff in front of you, and the light can't travel so far. We have night. It's not that difficult, really.
I mean, it is though because what you just laid out does not make sense to me. Like, how is something that's really really high in the sky? How is that light getting obstructed by something that's really really low in the sky?
Okay? Because the horizon
Uh huh.
rises to eye level, only does that at 3 miles distance if you're standing at sea level. And most of us aren't at sea level. We're on land. We've got shit in the way. And shit gets in the way. But 3 miles isn't very far at all. But that's where it gets limited by. And the convergence factor just makes it appear to go lower as it gets further away. It's
Yeah, it gets closer and closer to the horizon as it gets farther and farther away.
yeah,
True,
but
but
your
it
but your
never gets
horizon is still
obstructed.
only a few miles away.
But it never gets obstructed by the horizon.
So
In
if your
perspective,
horizon was that many thousand miles away,
yeah.
technically you should be able to still see the sun, but your horizon isn't. Your horizon is only a few miles away. It's fuck all. It's nothing. It's always there. It's always going to be converging up. Just as you
Yeah.
look down any road, the road appears to converge up to the convergence point. Even the street lights going down to it only happens in like a couple of miles at the most.
I
Sometimes you
would
might see a bit further.
I could push back against the point that the horizon always rises to eye level, which isn't true. I could show you things for that, but I still am not hearing an explanation for why it disappears bottom first. Because it shouldn't like the whole thing should just get dimmer and dimmer and smaller if perspective was the only thing in play.
Yeah, well, it isn't the only thing in play. That's the whole thing.
So
There's
then what
multiple things.
what is blocking the view of the sun bottom first?
The land in front of you, all water.
So
That's
for
what's
the
blocking it. And then you've got the atmosphere itself. So as the sun gets further and further, because
so
it's
for the
going
individual, like,
really, really, really big distance, like to go around the equator once a day, if we agree that the equator is 25,000 miles, the sun is actually moving pretty quickly. It's almost a wonder
so
that we do see it for nearly half the day every day.
just think about the light that's originating at the sun, and it's making a straight line to my eye during a sunset when I look at the sunset. So there's a straight line that the light is traveling. So how is it that the land itself can possibly obstruct the bottom of that light, but not the top portion of it? Like, how can the land possibly do that if the light from the sun is making a straight line to my eye?
I'm wondering what you're actually talking about here. Like, have you used like a camera to zoom in on it as
Well,
it's doing this? Or?
you told me earlier during this discussion, when we were talking about bouncing light off the moon, you made a point that the light only travels like in that one direction in a straight line. You'd made that point. So now I'm just asking you, for the light that originates at the sun during a sunset, that light is traveling to a straight line to my eye where I am watching the sunset. So how is it that there's any land that can possibly block the bottom portion of that light?
How is there could be any land?
Yeah, you said that the bottom was being obstructed by the land of, like, that's the horizon.
Yeah.
So how
And your
is it that
horizon meets your eye level at 3 miles, and you can't see any further than that. So anything further away, as it gets further away, it's blocked by what you can't see.
Yeah, but I'm asking you to think about the light, like the path that the light takes
Yeah.
when it travels
Well,
from the
well, that's
sun.
when you see it get obscured by the things that are on your convergence point, man.
But how is it getting obscured? Because again, the light is traveling from the sun to my eye when I'm watching a sunset. It's going in a straight line from the
Technically.
sun to my eye, right?
Well, you're seeing your perspective of it for sure.
This is not from my point of view. This is from the light's
Well, it
point of
is.
view.
How else are you going to see it? The
I'm
only way you can
asking
see
you
it is with
to
your eyes.
I'm asking you to do a thought experiment here from the light's point of view. The light that originates in the sun and travels to my eye. It's traveling in a path in real space, you know? It's existing. It's
Oh,
traveling
so
from the
yeah,
sun
right.
to my eye. So in its pathway, that's a straight line from where it starts in the sun to get to my eye. How is it that something so close to the ground or the ground itself could possibly obstruct it? Because it has to physically block the light.
Yeah. Well, so maybe there's something up there that's where the light is shining through that gives us the apparent sun that we see.
I'm
The
trying to.
firmament. Yeah, we're just seeing our own subjective experience of the sun.
So does the sun really exist? Do you think, or does everybody just
Oh,
have their own
well,
personal sun?
definitely. The best example I use, really like to use, is if you think about a lake that's frozen over and there are fish living in the lake. So it's pretty cold water. These fish have adapted to that really cold water. And so there's a layer of ice on top of them. And whenever they look up through the ice, that's where they're going to see their subjective sun. And for all intents and purposes to them, that's their source of light and heat and everything. And it doesn't matter where they go in the lake, the sun's sort of going to follow them as they go until eventually the sun comes in and out of view. And we're sort of living a little bit like that, I reckon. Just we're
So
seeing a subjective version of it, but it could potentially be in a million different other places. There are other millions and other fish in there.
so then,
At the
okay,
same
so
time.
you're positing the existence of this firmament. So how can we test whether or not this firmament actually exists? Like, what kind of experiment can we do?
That's a really good question. And yeah, I think that's what we've been trying for a long, long time. I think all the space agencies are trying it. And, a lot of people are sending up, weather balloons and stuff, and it seems we can't really go as high as we like to think.
Why would you say that? What makes it seem that way?
I've never seen any evidence of going up more than about 50 or 60 miles or something, maybe 70 miles.
Um, you've never seen, so you don't think that we've ever been to the moon or Mars? Like we've never sent any probes there? I didn't hear you. I don't know if you're muted or.
I said, no,
Oh,
I
okay.
don't think.
So like all of these agencies and like they're, you know, I mean, what about private companies? Like, I mean, they're not going quite as high, but like still they have satellites like like Starlink, right? With Elon Musk. I mean, he's sent an array of satellites that, I mean, they provide internet wherever you're at.
Yeah, that's interesting.
I mean,
I
that
really
couldn't
can't.
be land based because it can provide, you can get, internet in places that you wouldn't be able to connect with a land based system.
Okay, I find it more unlikely to be able to connect with a space-based one.
But you can see I mean, you can just see the results for yourself. You can get Starlink for yourself. Just try it for 1 month and take it someplace where you'd never be able to get land-based coverage, and you'll be able to see for yourself.
What are you trying to sell me the internet now or something?
No, I'm just saying, like, a lot of these are easy to test for yourself if you're dubious.
Look, I'm not saying there's not technology around that can't be explained, but at the same time, how does that prove anything one way or the next? Like,
Well, it just proves that we've been sending stuff into orbit.
yeah, yeah, I just can't buy that things can go into orbit if we're in orbit. I can understand things can be floating up there, not a problem. It seems pretty simple to me, but to be in orbit,
You just have to impart enough tangential speed into an object
yeah,
to prevent it
yeah,
from falling to the surface. If it's traveling fast enough, then its own speed will prevent it from falling to the ground.
yeah. But the Newton's laws of motion say a thing in motion will stay in motion unless another force acts upon it.
Yeah,
And once a
unless
thing
another force
just
acts
misses
upon it.
something once, it will keep on going in a straight line and keep on going until something else resists it. So it's not going to keep orbiting. To
Yeah,
me, it
so
makes no
that
sense.
shows us that they're gone beyond an atmosphere because they're not being slowed down by the friction of the atmosphere. So the fact that you
Yeah,
can have like a geosynchronous orbit kind of shows that they're beyond Earth's atmosphere and they haven't hit a firmament or anything.
yeah. Just getting a little bit windy out there.
So what about the flight times in the southern hemisphere then? Um, like, have you ever done the trip from like Sydney
Yeah,
to
I'm not a flight
Santiago
expert.
or
So I'm not
Sydney to Johannesburg?
no, and that's why I can't really comment on it because I don't know enough about it, and it's not my area of expertise.
Right.
But
Well, I think that you could pretty easily, like, you don't have to do these flights yourself to see, like, I mean, if you just Google like the tickets, it'll tell you how long the flight takes. Like, and you could look on that map behind you with the flat Earth, and you should try to plot the route, and you could compare it to the same kind of flight times in the northern hemisphere, and you can see that the flight times only make sense on a globe. Like, if you actually chart out these flight times, you look at, okay, it takes me 14 hours to fly from Sydney to Johannesburg, South Africa, and it takes me 14 hours to fly from like New York to Dubai, and then you look on a flat Earth map and that doesn't make sense. But then you look on a globe and then the flight times do make sense. Like if you just do this comparison yourself, I think that you could prove to yourself that the Earth cannot be flat.
yeah, I think I've seen plenty of flat Earth maps that just show the way the winds actually blow, and it's oddly enough it goes faster than the direction of the Earth spinning. So when you're flying from east towards the west, you can pick up a great amount of speed. So from flying Sydney to San Diego, yeah, you can do that 13 or 14 hours or whatever. But they never come back the other way. They always go.
But they do come back the other way. You can
No, they all go via North America, and it takes like 30 hours, 40 hours.
No. I'm telling
Yeah.
you, like we could look at it right now, but whenever because I just did
Yeah,
this.
they might look like they exist, but if you actually try to do it,
But
you'll
you
find
can do it.
flights
I'm
always
telling
go.
you, like these flights exist. We can look at the flight number and we could track it ourselves. Like that, you can get a direct flight, and then it'll tell you the same direct flight going back. So it gives you the time to go there and the time to go back, and those are both real flights. I mean, there are people on
Yeah, but
board
at the
them.
same time, saying that they're real flights and actually existing, not being cancelled and transferred to something else if you're actually doing it, from people that have actually done it.
I mean, but anybody can verify this for themselves. I mean, there are those flight tracker websites, and then you can literally just physically go to the airport and watch as the flight that you're tracking lands, and you can look at the direction that it's coming from, and all that's free. You don't have to buy the flight to do any of that.
Yeah, as I say, it's still not my area of expertise, but
I
I'm
just
just
find
saying
it,
it's
I just
entirely
find it to
possible.
be
Yeah.
one of the most easily accessible ways to prove to yourself that the world cannot be flat. Like the flight times just show it definitively.
Hey, wait. The times,
Yes.
all the other evidence of it actually looking flat, being flat, never having to adjust for curvature, never seeing curvature. It's
Yeah, the flight times.
for rotation, spin, all the other
Yeah.
things that you believe in. Once you leave the ground, you have to take all those momentums into account and never have to adjust for a single one of them because of some crazy law of
Yes, the
motion.
flight times trump all of that. Yes.
No. Flight tells us that the Earth is flat and stationary, man. You can't
It
do it
does.
any other way. You couldn't possibly land on moving ground that you've taken off and gone different directions on. It's just
Well, do you
impossible.
understand how the conservation of momentum works? Like once an airplane takes off, it hasn't suddenly lost all the momentum that it had while it was on the surface.
Yes, it is.
That's not how conservation of momentum works.
No. It takes zero motion, comes its own motion, and it's moving. That's all it's doing.
No,
the
but
staying
relative to
still.
the Earth's
The Earth
surface,
is staying still.
but relative to the Earth's surface, it has not lost
Yeah,
any momentum.
that's right. Because there is none.
No,
Simple as that. Simple as that. That's the end of the story. You don't
I'm
have to
telling you,
invent
like
all this imaginary shit just to make a belief that you spin around the sun is reality. Dude, what is wrong with you?
I mean, there's nothing wrong with me. I understand this pretty well. Like you're not losing any momentum when an airplane takes off. You still have the same momentum you had before relative
What
to the
about if you
Earth's
jumped
surface.
off the airplane?
Yeah, you would still have the same momentum.
As the airplane?
Yeah, when you jump off and then you're slowed down by air resistance.
But there's no air resistance. Why does air resistance make you appear to go still? It doesn't make any sense.
Why does why does it doesn't you don't appear to go still.
Well, you do relative to the ground once you've left the momentum of the plane.
Yeah, you
So we've
don't.
taken off with the momentum of the earth and the plane and the wind. And then you jump from the plane, but you lose the plane, and then you just go with the wind, but to make you look as though it's
Look,
falling straight
if
down
you
to the
jump
ground.
out if you jump out of an airplane and just say it's moving at like 500 miles an hour or whatever, the moment you jump out, you're initially still traveling that 500 miles an hour, and you have to be slowed down by the air resistance. So maybe like 2 seconds later, you're traveling at 400 miles an hour, like whatever. It's gonna drop off. It's not just all of a sudden gonna go from 500 to 0.
And
It's
yeah,
a gradual decline as the air slows you down.
and yet the earth is supposed to be spinning just 1,000 miles an hour.
Yeah, because there's nothing like that's providing friction for the earth spinning. Like the air is what's providing the friction to stop you from moving. But you talked about Newton's first law earlier, like an object in
Yeah.
rest will continue at rest unless acted upon by an outside force. So the force that's acting upon you when you jump out of the airplane is the air that you're traveling really fast and the air is like resisting you, so you're slowing down. But for the earth to be traveling at that speed, there's nothing that it's encountering that's resisting it. There's no air in space.
I know. That's why it sounds so ridiculous to assume that then it could be moving freaking millions of miles an hour in multiple different directions in order for the heliocentric model to even make sense.
I mean, that just sounds like you're
Man.
being incredulous, but I'm not hearing like an actual logical
Incredulous.
reason.
Well, yes, I am incredulous that somebody could believe that. That when we just see the plane take off at the speed it takes off, it can spiral around and around through the air. There's a certain amount of wind or whatever, and the skyjumper jumps out and he falls back down to the ground. And there's not even a hint of any motion of the earth going a fucking 1,000 miles an hour times 66,600 miles an hour plus
Yeah,
514
it's because
million miles an hour following the sun another direction. There's just no evidence of any of it whatsoever. So why would you even think that we should have to consider it? It's
I mean there
insanity.
is evidence of the Earth's motion,
There's not.
but in that
There's not.
example,
There's
in that
not.
in
There's
that
none.
exa- in that
There's fucking
example,
none. The plane takes off, the ground stays still. That's
so
it.
in that example,
That's it.
everything was still moving with like the Earth's momentum, right? You just describing an experiment with a skydiver within the frame of the Earth, like the Earth's surface as your reference frame. But again, the air is moving, like the whole Earth is moving.
How?
So how?
How? Fucking yeah. There's no way that you can just say fucking magic gravity is pulling us all towards the surface of a spinning
Well,
ball
there's
going
an
on some
annual
vacuum.
Doppler effect.
Come on, man. Like
There's an
fucking hell.
annual
This is
Doppler effect that's
2023.
observed.
Get with the times, God.
I mean, we
There's
can
what?
observe the Earth's motion, like when we look at
Observe
the stars.
the
Like,
Earth's motion by looking at the stars.
yeah, there's an annual Doppler effect where we can observe the direction that the Earth is moving based on the Doppler shifts in the direction of the sky.
No, I would have just thought that would have showed us the stars moving, but if that's if that's what you like to believe, man, hey, like I'm not going to convince you that you know
Well, there are optical
your belief
experiments.
is wrong, of course, but I just think it's an interesting way of looking at things.
There are optical experiments which can show us like the Earth's motion. Like there's
Or the
also the
stars.
fact that a sidereal day is a slightly different time than like a solar day, which is possible because the sun has slightly changed positions because the earth is revolving around it. So that explains the difference between a sidereal and a solar day in their lengths because of the revolution of the earth around the sun.
That'd be nice if there was evidence for it, but the
There
fact that
is.
I do see the Southern Cross
Yeah.
every night of the year, all year round, year
Yep.
after year after year, proves that that is impossible. I'm not far enough south, I'm 28 degrees south of the equator here. I see the same stars all year round. It's just impossible that if nighttime it's facing away from the sun in a heliocentric model, that
Mhm.
that would mean all the stars are going around the sun, and that's why I think
Mhm.
it's just ridiculous. It
Well,
just doesn't
you
make sense.
because the Southern Cross is centered around the Southern Pole. So,
Yeah,
like
yeah, and it's way over the southern pole at freaking 90 degrees above the southern pole, the
uh-huh.
so-called South Pole. It's
So
impossible.
if it's centered on the axis of Earth's rotation, then why I don't understand why you're shocked that you can see it, like, not moving in relative in the sky.
All year round in the same direction
Yeah, but why is that so weird to you?
because uh, if night is looking away from the sun and we're orbiting the sun,
Mhm.
then all the stars every 90 degrees would be completely different. At nighttime, if that's what was going on, then it's only us and a handful of
Except for
planets
the
going around the
stars.
sun.
Yeah, except for the stars that are along Earth's axis of rotation, though, which is like the Southern Cross. Like it's true. Like at night, you do see the stars in different locations, except like the Southern Cross is obviously not changing because the Earth's rotating and along an axis, and that axis points towards the Southern Cross.
It's getting a little
It's
bit
kind of
quiet
tough
here.
without a visual, but I mean, on a flat Earth, how would you explain how when in Australia you look south, you see the Southern Cross, but at the same like at the same night where it's nighttime in both, you can look in South America and see the Southern Cross when you're looking south, but on a flat Earth model, those are two different directions.
Yeah, dude, I can barely hear you here.
Oh, really? I haven't changed anything about my audio settings.
No, the rain's getting a bit loud, and all of a sudden, I'm like
Oh, hey,
looking for a way to turn up the volume, and I think it's as loud as I can get it.
it's raining here too.
Yeah, right, yeah. Maybe I need headphones. I don't know.
Yeah, actually, I can hear the rain on your end too. It's louder
Yeah,
than the rain here.
yeah, and it just sort of come out of nowhere. So yeah, sorry, what was that last question you asked?
Oh, I was asking how it could be possible that when it's nighttime in both Australia and in South America, how when you look south, you'll see the Southern Cross looking south in both of those places, but on a flat Earth, those would be different directions.
Yeah, no, that is pretty weird, and that's where I think there is some sort of answer to that, and that's to
What
do
would that
with
answer
the
be?
that's to do with the actual firmament that we're looking at. Might perhaps be something other than what we thought.
Like what?
Like more star tetrahedron shaped, like two intersecting pyramids type of thing. And as it rotates, night and day sort of change in gradual portions at a time. And so once you're outside of the equator, the people sort of looking south are seeing a facet of something that looks the same to them, but it's 90 degrees different in their facet at the time. Then it keeps sort of rotating around.
Um, is there any like simulation or mathematics to help explain this?
Like, I can barely hear anything.
Um, Well, if you cannot hear me that well, then maybe we should finish this conversation at a later time. Then,
Maybe, yeah. Yeah, I might have to stop this. It's ridiculously loud here.
all right. Well, thanks for having a pleasant conversation, Iron
Yeah,
Horse.
no
It was
worries, man.
definitely,
Good to catch up with you again.
yep. There was no rudeness or yelling or anything. Um,
Of course not.
and yep. I enjoyed this definitely. Also look out because I've been trying to get a debate in with Witsit. So he's been ignoring my messages, but I talked to him over the weekend and he said he was down for it.
Yeah, cool. That'd be good. Yeah, no, I'd like to see you guys have a chat. That'd be interesting.
Yep. So, anyways, peace out. Have a good night.
All right,
Enjoy the
Jason.
rain.
Yeah, very good one, bro.